Hi, this is Mrs. Myers, and we are going to be doing lesson 3.2 today, properties of parallel lines. We talked about parallel lines previous to this lesson, but today we're going to prove theorems about parallel lines, and we're going to use the properties of parallel lines to find angle measures. So first of all, remember we learned what a postulate is. A postulate is something we accept as being true without proving it. So the first postulate we're going to learn is the same side interior angles postulate. And it says if two lines are parallel, in this case L parallel to M, then same side interior angles are supplementary. So in this case, angle 4 and angle 5 are two angles that are on the same side of the transversal. They're on the interior of the parallel lines. Remember we learned interior means between the two lines. So this yellow part is the interior. So angles 4 and 5 are same side interior angles. And angles 3 and 6 are also same side interior angles. When you have same side interior angles, they are supplementary if and only if the lines are parallel. So measure of angle 4 plus measure of angle 5 in this case would equal 180. We can use this postulate to prove the other angle pair theorems. So all of these next few theorems are saying the same basic thing except with different angle pairs. First they're saying if the lines are parallel, then certain angles are congruent. The first theorem talks about alternate interior angles. Remember, interior again are between the two lines. Alternate means on different sides of the transversal. So in this case, angle 4 and angle 6 are congruent, and angle 3 and angle 5 are congruent because they are alternate interior angles. Sometimes with alternate interior angles, we notice if I draw this angle, angle 4, I can trace it like this, and then I trace angle 6 like this, it looks like a Z. So think about the Z when you're looking for alternate interior angles. When you go the other way, kind of a, backwards looking Z, but it's still that zigzaggy kind of tracing of the angles. Okay, so this is a two-column proof actually proving, or we're going to see a two-column proof actually proving this theorem after we talk about the next few theorems. So the first one, if the lines are parallel, then alternate interior angles are congruent. The second one, again, if. The hypothesis is the same. If the lines are parallel, then corresponding angles are congruent. Well, in this case, corresponding, remember, they're on the same side of the transversal. They have a different vertex. One's on the interior, one's on the exterior. That's what corresponding angles are. They're kind of in the same position, one from the top set of angles and one from the bottom set of angles. So if I kind of trace this angle 2 and I slide it down the transversal, it would cover over angle 6. So 2 and 6 are corresponding. I could do the same thing with angle 3. Slide it down the transversal, and 3 and 7 are in the same position, top and bottom. Those are corresponding angles. So if the lines are parallel, then corresponding angles are congruent. The last theorem says alternate exterior angles are congruent. If lines are parallel again. So 1 and 7 are alternate exterior angles. Exterior, remember, if the interior is between the two lines, the exterior is going to be not between the two lines. So up here and down here, these are exterior angles. So angle 1 and angle 7 are alternating sides of the transversal, different sides of the transversal, both on the exterior, and then 2 and 8. So those are alternate exterior angles. And this theorem says if the lines are parallel, then those special angle pairs are congruent. So we've got, if the lines are parallel, you have all of these situations. You've got alternate interior angles congruent, alternate exterior angles congruent, and corresponding angles are congruent. Don't forget, same side interior angles are supplementary. So everything else said congruent, but same side interior angles are supplementary. I like to think of same with the S side with another S, supplementary. Same side, supplementary. Okay, so we can prove these theorems by using what we know about proofs. Oops. So here's the diagram. What did I do? I jumped down there. Here we go. Alternate interior angles theorem. Given lines are parallel. So if we know the lines are parallel, we're going to prove that the alternate interior angles, 4 and 6, are congruent. Notice if lines were not parallel, you can clearly see that these two angles would not be congruent, right? These relationships only work when the lines are parallel. So we have to know first that the lines are parallel, and then we can, in this case, we're going to prove alternate interior angles are congruent. So we're going to start with L parallel to M. That's given. First, we're going to name them for what they are. 3 and 6 are same side interior angles. We're talking about 3 and 6 because we have our postulate that tells us that same side interior angles are supplementary. So we're going to start with something we know. 3 and 6 are same side interior angles. Remember, every time you name something just for what it is by looking at the diagram, it's definition of that thing. Definition, in this case, of same side interior angles. Then we can say that 3 and 6 are supplementary. Well, why can we say that? Because of the same side interior angles postulate, which is what we just learned at the very beginning of this lesson. Now, by definition of supplementary angles, we could say the measure of angle 3 plus the measure of angle 6 equals 180. You should have guessed that one was coming, right? Now we can change gears a little bit and say 4 and 3 form a linear pair. Look at the diagram. 4 and 3 form a linear pair. Just by looking at the diagram, we name them for what they are. That's definition of a linear pair. Linear pair postulate. Remember, the postulate says that they're supplementary. So 4 and angle 3 are supplementary. Well, of course, if they're supplementary, we know we can say the measure of angle 4 plus the measure of angle 3 equals 180 because of the definition of supplementary. Measure of angle 4 plus measure of angle 3 then equals the measure of angle 3 plus the measure of angle 6. Well, let's see. We have 4 plus 3, which we had here. We have 3 plus 6, which we had here. And they're both equal to 180. So now we can set them equal to each other. Hopefully you remember why. Substitution. Two things are equal to the same amount. We can set them equal to each other by substitution. Now we have a measure of angle 3 on both sides of this equation. We can make this the measure of angle 4 equals the measure of angle 6 by subtraction, just subtracting the measure of angle 3 from both sides. Well, if 4 is equal to 6, then angle 4 is congruent to 6. Definition of congruent. So if you think about the logic here, we were given that the lines were parallel. And the only thing that we know for sure is that these two things are a linear pair, and these 2, 3, and 6 are same side interior angles. We're able to use our information. We know linear pairs are supplementary. We know same side interior angles are supplementary by our postulates. So we're able to then say 4 and 6 are the same measure and therefore congruent. So we've just proven the alternate interior angles theorem, which means from now on we can use the alternate interior angles theorem in proofs. Okay, now we're going to prove the corresponding angles theorem. Again, we have two lines that are parallel. We're trying to prove that 6 and 2 are congruent. Corresponding angles, 6 and 2. If you look at this diagram, what do you know? Well, I see some same-side interior angles. I see 2 and 3 are a linear pair. I see 1 and 2 are a linear pair. So all of that knowledge is going to help us to prove that corresponding angles 2 and 6 are congruent. So again, we start with our given that the lines are parallel. 3 and 6 are same-side interior angles. Again, definition of same-side interior angles. 3 and 6 are supplementary. Sounds familiar, right? This is by the same-side interior angles postulate. Which we learned at the beginning of the lesson. Now we look at our diagram. We say 2 and 3 form a linear pair. That's by definition of a linear pair. So we can say angle 2 and angle 3 are supplementary by the linear pair postulate. Remember, the postulate says supplementary. So angle 6 and angle 2 are congruent. This is that theorem from chapter 2 that says if two angles are supplementary to the same angle, remember we said if we have angle 1 supplementary to 2 and angle 1 also supplementary to 3, then 2 and 3 are going to be congruent to each other. That was a theorem we learned in 2.6. But here we have 3 and 6 are supplementary, 3 and 2 are supplementary, which means 6 and 2 are both supplementary to angle 3. 6 and 2 are both supplementary to angle 3. So we can say 6 and 2 are congruent to each other by the congruent supplements theorem. Congruent supplements theorem. Okay, so alternate exterior angles theorem. I'm going to let you try that a little bit on your own. And then we're going to do a proof using the theorems. And then the last page of your notes is some practice and some justification. I'm going to let you do that on your own as well, and we will check it in school. So let's go straight to this theorem. This says given that A and B, line A and B, are parallel, prove that 1 and 8 are supplementary. 1 and 8 are supplementary. So we're going to start with A parallel to B. Then we're going to say definition of corresponding angles. We're going to name a pair of corresponding angles in this diagram. There's only one pair that are numbered. You see what they are? Should be angle 1 and angle 5 are corresponding angles. Just by definition, we can look and we can identify them. Well, what does the corresponding angles theorem say? We just proved it. Just a minute ago, we proved the corresponding angles theorem right here. It says that corresponding angles are congruent. Wait, that wasn't the proof. Here's the proof of the theorem. Corresponding angles are congruent if the lines are parallel. So since we have this proof here, we know A and B are parallel, we can now say that angle 1 is congruent to angle 5 by the corresponding angles theorem. We've proven it, so we can now jump straight to that conclusion since we know the lines are parallel. Therefore, we can say the measures of these angles are equal by definition of congruent. And we can say angle 5 and angle 8 form a linear pair just by looking at our diagram, definition of linear pair. Remember what our next logical step is? Angle 5 and angle 8 are supplementary by the linear pair postulate. Measure of angle 5 plus measure of angle 8 equals 180 by definition of supplementary. Now look what changes. Measure of angle 1 plus measure of angle 8 equals 180. Looks like we just took out the 5 and replaced it with the 1. So that's substitution. Then we can say angle 1 and angle 8 are supplementary by definition of supplementary. If we know they add up to 180 in this step, that means they must be supplementary by definition of supplementary. Okay. At this point, I'd like you to try to fill out this proof on your own and try to do the problems on the last page of your notes sheet. You do not need to do this homework from the book. Okay, so just do what we left blank, and I will see you tomorrow. Remember that when you have alternate interior angles, they're congruent. When you have alternate exterior angles, they're congruent. When you have corresponding angles, same position, top and bottom, they're congruent. And the only one that's not congruent but supplementary would be same side interior angles are supplementary, add up to 180. So keep that in mind. Notice that whenever you have parallel lines cut by a transversal, you've created 8 angles here. It's only 2 measures, because all 4 of those are the same. And all 4 of those are the same. So you really just have 2 measurements in this set of 8 angles. Okay, good luck.